Normally, these types of videos would have much more of a long-winded introduction, but based on the theme of these videos, that introduction is actually going to be at the end of this video. So if you'd like to learn more about me and my project Tales of Tour Rest, make sure to stick around at the end of the video. Until then, special thanks to our patrons at the time of recording. Other than that, grab your Red Bull, set up your Minecraft automation window, and let's get started. Hello everyone, today I am teaching you the basics of Unity in Unity 6. I'm currently upgrading my main project from Unity 2022 to Unity 6 and thought this was a good time to learn how Unity 6 works. So we're going to start a new project. We are using Unity 6 in C# and Universal 3D. So once you've installed the Unity Hub, we'll see this screen and you can click Create New Project. Let's call it Tutorial. I'm actually going to store it in a different location than I normally do, just to not throw off any of our Git problems. I will make a video for Git later, but for now we can ignore it. Oh well, this already looks completely different. This isn't what I'm used to at all, but I have it set up so that this is what it should look like for you when you get into Unity for the first time. Beyond that, let's just go through some quick things that we can change. Personally, I use light mode for Unity, but feel free to change it if you prefer, and here's how you do that. So down here in Edit, we can click on Preferences. You can go General, and then over here you can change from white to dark. While we're here though, let's also check out Colors. This one here is our Play Mode tint. By default, this is set to a light grey. Unity can run in editor mode and playtest mode, however any changes during playtest mode are not saved to the project, so you want to make this a very bright colour that stands out so you can tell what mode you're in just at a glance. I personally like making it a very bright pink. Additionally, we can also go to external tools, and you want this to be set to some kind of Visual Studio. By default, this was set to open by file extension, however this is not what we want. Now we have a lot of windows here that I've rearranged them so that they'll look like what your screen will probably look like, but you can move these windows all around, edit your workspace any way you like. Now when we're looking at our screen, right here in the middle we have our scene window. This shows us the scene we're working on right now. Think of a scene like a level in a game. Everything on the map, everything that's currently existing right now in this instance of the game is in the scene in this window. Next up is our game window. This is what it looks like through our camera. Every scene needs to have a camera to render itself, and when we look through the camera, that's what we see in our game window. So we can see if we move this camera side to side, it moves the game object side to side as well. But remember, the game object itself isn't moving, just our view from the camera. Over here on the left is our hierarchy. This is very important. The hierarchy lists all of the game objects currently in the scene. If we drag an object onto another object, we see that the object becomes indented underneath the first one. This is parenting. Think of it like grouping objects together. If we parent an object to another object, it becomes a child. Below here we have our project window. This is basically where we keep all the files in our game. As you make a game, this is going to get very bloated and overcrowded. Basically, every file, image, object, script that is in your game is going to be in this window at some point, so it pays to be very organized. The next window over is our console window. This console window sends us a message whenever we trigger errors or warnings, and we can also use debug methods to send ourselves custom messages when we need them. And over here on the right is the inspector. Now this window shows us all the information on whatever we have clicked. So if I click on our game object in the hierarchy, the inspector window now shows all the components and information on that game object. Back to our speech on game objects. This is a game object. There are lots of game objects, but right now this one is ours. Everything in a game is a game object, whether it's the player, an enemy, a bullet, special effects, the lighting, a fire, the time, the inventory window, an item you pick up, even the horse. Everything you can think of in a game is made up of game objects. Now, game objects can have many properties that are controlled via components. They can be invisible to the camera, They can be impassable or pass through other objects, and they can be any shape we want dependent on the object mesh that we use. Now, game objects have components. It's how games work. Every single game object is going to have a transform component, which is this one here at the top. Transform components determine our position, our rotation, and our scale based on the world position. If I move our object around the scene, you can see the position values start to change. Our position values are determined by the distance between a point in the world called vector 0 or 0, 0, 0. If I parent a child to this game object, we actually see our transform values change. This is because once a game object is a child, the values are no longer correlated to the world position, but the difference in the position of the parent. If the child and the parent occupy the same position, the child's position is going to be to 0. If we move it 1 unit to the right on our x-plane, we see our x value changes to 1. Now, there are some quick hotkeys that we can use to manipulate game objects in our scene. W changes our position. If I press E, it switches to rotation mode. I can spin the object however I like, and you see that the rotation changes. And then if I press R, we get our final one, which is our scale. And you can see I can change this into whatever I need. Now, there's a couple other components on this object because we've created it as a 3D object. This component is a mesh filter. Unity comes with some pre-built shapes. If we right-click in our hierarchy, we can actually create 3D objects straight into the scene. Let's create a sphere as well. We'll move this sphere just over to the left, and you can see that this one has a sphere mesh filter, whilst our first is using a cube mesh filter. You can actually see the mesh filter here, indicated by this small green wireframe. That's how the object exists in the physical space. The next component is the mesh renderer. You might have noticed I keep turning this on and off. The mesh renderer basically means this object is going to be rendered by our camera. If we turn it off, you see the object actually disappears. We can still see the wireframe, but that's only because I have the object selected in scene view. If I switch to game mode, the cube is completely gone. If I bring the mesh render back, it reappears. Colliders. Now, a collider is basically the object in physical space. The colliders come in the same basic 3D shapes, and we can also use a mesh collider, but this is usually not a good idea, as a cube or capsule collider is much less performance taxing. This provides information to Unity on how the object should react to the physics system. This true or false setting trigger is important as well. If we click this to true, the object becomes ignored by the physics system, so objects will freely move through it. However, this means that Unity does keep track of every object that does pass through it. So really quick, I'll create a plane and we'll use it as a ground object. We'll lift a cube slightly into the sky and then readjust our camera. Now, it is kind of hard to see both the cube and the plane at the same time, so we're going to have to make a new material to change their appearance. In our project window, we're going to create a folder, name it materials, very important to keep your asset folder organized. We're going to right click, create, and we're going to create a new material. Now we're just going to call this cube, and we're just going to go over here to our inspector. Our inspector also opens object in the project window as well. If you open an inspector window and you don't want it to change when you click somewhere else on the screen, you can press the lock symbol up here in the corner. And no matter what we press now, the inspector won't change. Let's turn it off and go back to our cube material. Now, I don't use materials very often, but I can quickly use it to change an object's colors just to know how things work. Right here we have our surface inputs, and this is our base map. Our base map is basically the color of our object right now. So if I click that to edit, you see I can now drag on this color wheel and see that my changes are being applied to the object preview down here in the corner. All the changes we make to our material are displayed on this preview. We can click this button here and cycle through a bunch of different shapes. Because we're applying this to a cube, let's look at our preview of a cube. Now we can decide if it's metallic, let's go very metallic, and we can decide how smooth we want to make it as well. So right there, it looks like it's got a nice little sheen to it as well. Now, normal map, height map, occlusion maps, and even base maps, that kind of stuff you'll learn if you're an artist, and that's how you can put in details and other textures. But for now, we don't need to worry about that. Now we've got our material, we know what it looks like on a cube, but it's not on this cube. How can we do that? How can we apply this material to that cube? We can go to our cube in our hierarchy, and in our mesh render, we actually see we have a section for materials. Right now, it's just using one called lit. We can click on this window to select one from our project, or we can click on this and drag it up here to change it manually. Materials also do a very fun thing. When it comes to materials, you can drag the materials straight from the project window onto the object in the scene window, and it will change. See, right now we're hovering the mouse above the ground, but we don't want to change the ground, we want it on our cube. So let's drop it on our cube, and now in our game window we can see the difference between the cube and the ground. Okay, very quickly we're going to show one more component. This component gives the game object access to the physics system, and it's called a Rigidbody. Rigidbodies provide us with some details about physics. So you'll see here I have an option here called Use Gravity. I can choose whether that's on or off, and that applies gravity to this object or has the object ignore gravity. So now if I hit play mode up here in the top again, remember when I hit play the screen is going to turn pink. And now we see that our object falls to the ground, just like that. What we've just seen there is that the Rigidbody takes control of this object and it's using gravity. If we turn gravity off and enter play mode again, we see that the object won't fall, but it's still going to react to physics. So let's duplicate the object by pressing Ctrl D, and you'll notice that the two objects appearing in the same space actually pushes them away. And we can do it again and 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 again, and it just becomes this big crazy mess. The reason that the cube is stopped on the ground is because the cube has a Rigidbody and our plane has a mesh collider. If I turn the mesh collider off and then enter play mode, the ground plane will no longer react to the physics system. Let's make sure to turn gravity back on, and we see that our cube falls right through the plane. It falls through it because the physics system does not detect the plane because the plane no longer has a collider. Now we want the physics system to work, so we're going to turn our mesh collider back on, and when we press play we see that the Rigidbody reacts with the plane, again coming to the stop. Now let's go and create another cube, and let's put it right underneath our first. Let's make it a weird size and rotate it a little bit. Now if I take the second cube, I don't want this to have its own physics, so I'm going to remove the Rigidbody component, but I'm going to continue keeping the box collider so that the physics system can detect it. It's just the object itself has no physics information. So now when I press play, our object collides with that new cube and rolls down to the ground. Why have I shown you that? It's because I want to show you the isTrigger function on the collider. isTrigger changes the collider so that other objects can pass through it. An object will pass through it, but the game will recognize that an object has passed through it and send that message into the system. So if we enter play mode now, even though it's got the box collider, the physics engine will still just have our first cube drop right through it. What's the point of this? Well, the main point of this would be in a scenario where we make this second cube see-through, and when the other cube passes through it, this would send an event call to our game saying, hey, our cube has just passed through this area. This is how we can activate doors or trigger cutscenes. The really interesting thing about Unity is that it actually lets us write our own components. You can see here at the bottom it says new script. So each of these components we've been looking at are actually scripts. Unity gives us a bunch, like I said, an absolute mess of components that we can use. But you can't make a game using just the default components. You will need to make some of your own for gameplay. So we're going to start with a very simple script here. We're going to make a new cube, and we're going to move that cube over here to the right. Let's make a new material and make it a blue color. Let's call it new, drag it onto our second cube. So now in our game view we have two cubes. I'll just drag these other ones over here so the camera sees both. You'll notice I also dragged the invisible cube over so that it will stay under our first cube. Now we have our two cubes and we're going to create a new script. So we're going to right click, create folder, I'm going to call this one scripts. In here we can right click create and we want to write a mono behavior script. Now I don't like that Unity 6 says mono behavior script. I think it should just say script like it did in the old ones, but that's just how it's going to work from now. So we click this and it creates a new mono behavior, and we're going to call this trigger message. Now let's zoom in a little bit. This screen can be a little daunting if you don't know what you're looking at. Also, please just ignore my very much customized Visual Studio. I will make a video explaining all of this, but for now, these comments are good enough explanations for what they do. Start is called once before the execution of... this is terrible. That's terrible mess. No. Let's get rid of that. Start is called at the beginning of a scene, or when an object first appears in the scene. And then update is called once per frame. That's okay, that's fine. I will explain how all of this works, but for now, let's just put it in start. So this is going to start at the beginning of our scene. Let's put in debug.log. Debug.log is a method that takes in a message and sends that message to our console. We'll notice after we call the method, now we've got a little error here. That's because we've called the method, but we haven't passed our message through. So we need to put our message inside these two parentheses. We're going to type hello right here, and we're going to press save. Let's go back into Unity and enter play mode. Now debug.log sends a message to our console, but no message has appeared. Why is that? It's because even though we've created the script, we haven't put it in the scene. Now, so that we can see two things at once, I'm going to move my project window up to the side like this, and we're going to click on our trigger object. This is the object we're going to put our script on. The trigger object gets the trigger message script. Try and keep things simple. Now there's a couple ways we can do this. We can click and drag to put it on, and we'll see if we do that, it inserts itself into the inspector like a component. Trigger messages is now available. Trigger message is now available as a component on our game object, and it's also in our component menu that we can search for. It now appears here. So let's just go trigger message and see that the script gets added to our object, but there's nothing here that we really need yet. So let's very quickly just add some customization. We're going to go back into our script, and at the top we're going to declare a string by typing public string message. Then in our debug.log call, we're going to replace our hello with the message we've just declared. I'm now sending this message through to the console. So when I save this and exit Visual Studio, on our trigger message component, we now have a window where we can type the message we want to type. So let's say hello again and enter play mode. It sends our message to us because the start method is called the second we enter play mode, and that's exactly what we want. We do want it to do it a little differently though, so we're going to take it out of this method and we're going to write a new method. This one is called onTriggerEnter, and it comes with Unity by default. This method is called when an object enters a trigger space for the first time, and is the main purpose of the isTrigger option on a collider. So when our cube enters our trigger collider, this is going to run. We're going to put in our debug.log here, message here. Now again, this is a lot. Remember, I am going to do a separate video explaining scripts and the basics. For now, just follow along. If I drag my first cube over here to the side and drop it, we see nothing happens because I know the cube didn't touch the trigger object. Everything just falls straight to the ground. But then if we drag it back over our trigger box and drop it again, we see that the cube hits the trigger and that hello message is sent to our console. So let's change the message again. The cube has hit me, Theodore. So when our cube passes through, we get the updated message. We're also going to go under here, we're going to declare a reference to a public game object. Call it blue cube. So once again, before I made a declaration of a string, which is a series of words. Now I've made a declaration of a game object. If I go back into Unity, we see that our blue cube reference isn't pointing to anything. It says none here. There's nothing referenced, but I can drag my blue cube from the hierarchy and put it here. This is a direct reference or a link. So now we have cube num2 here. Back in our script, let's go back to our onTriggerEnter method. We're just going to very quickly add in that we destroy the blue cube, so that when this cube hits the trigger, the blue cube will disappear as well. Just like that. And now here is the promised intro. Game development is one of, if not the biggest obsession I've ever had, to the point where there are times in my life that I didn't even know I was doing it, making board games and card games out of A4 paper ever since I was a kid. Thanks to the huge outpour of support from my current project Tales of Tour Rest, I've been lucky enough to start focusing on game dev as a real career opportunity. If you'd like to support me on this journey, you can buy me a Red Bull a month over on my Patreon, which also gives access to all of my videos weeks before they release here on YouTube. Also, you can follow me on Instagram to see even more updates on Tales of Tour Rest. I'm Taren Boswell, and thank you so much for watching.